Hey, welcome back to my YouTube channel. I am Xavier Smith. Today I'm going to talk about dependent systems in calculus. So let's get into it. So if we have a matrix in row echelon form that has on the last row like 0, 0, 0, 0, 3, right? What you're basically saying is that this last variable, which usually you want like a 1, like you'd want a 1, 3, and you'd say, okay, z equals 3, right? Here you'd be saying 0z equals 3, which just cannot possibly be true because whatever z is, like, it just can't equal 3 because anything times 0 is 0. So you're basically saying 0 equals 3, which is not true. So if you ever get zeros and then like a 3 in the little number category, like if you get a number that isn't 0 in this last category and you get all zeros before it, there is no solution. Whatever you're trying to do, there's just no solution if you're trying to solve that matrix because you're saying 0z equals 3 and you're saying 0 equals 3, which is not true. Okay, but if you get a matrix in row echelon form that the last row is all zeros, what you're saying is 0z equals 0, which is true because whatever z is doesn't really matter here. You're just saying 0 equals 0, which is true. So what you'd say here is let z equal like a, which a is just another variable, and then you'd solve for the rest of the variables just plugging in a as z. So you'd have like 1 plus dA equals e, and then you'd solve and you'd get everything in terms of a. All right? Because then you'd have y in terms of a, and then you plug in y in terms of a and z in terms of a, and then you'll get x in terms of a. And then if you were given z at the end or something, you'd be able to solve for all of it. But you're able to put it all in terms of a, just say let z equal a, or let whatever this last variable is equal a. Okay, now let's do a dependent system. Okay, well, we have this system here, like 3, negative 3, 6, 6, 1, 2, negative 1, 5, 5, negative 8, 13, 7. Okay, so first I see that I can change places with row 1 and row 2, right, to get this 1 up there for row echelon form. So 1, 2, negative 1, 5, 3, negative 3, 6, 6. I'm writing this really small because it's not a big change. 13, 7. Okay, now I see that I have a 1 and a 3, right? I can multiply this row 1 by negative 3 and then add it to row 2. So negative 3 row 1 plus row 2 would give me like 1, 2, negative 1, 5. Then negative 3 plus 3 is 0. Negative 6 plus negative 3 would be negative 9. 3 plus 6 would be 9. Negative 15 plus 6 would be negative 9. Then we'd have 5, negative 8, 13, 7. All right, now moving on to the next one. We have 1 and 5. So to get this to a 0 in front, we can multiply row 1 by negative 5 and then add it to row 3. So negative 5 row 1 plus row 3 would give us 1, 2, negative 1, 5, 0, negative 9, 9, negative 9. And then negative 5 plus 5 is 0. Negative 10 minus 8 is negative 18. This would be 2, wait, no, this would be 5 plus 13 is 18. And then this would be 5 times negative 5. So negative 25 plus 7 would be negative 18. You can see this little pattern is appearing here. That might be important later. Okay, now we get those to be 1s in the front, right? You could get 1 to be a 1, or you could get this one to be a 1. But actually, what I'm going to do is, since they're like so simple right now, I'm going to multiply this one, like row 2 by negative 2, and then add it to row 3 just to get the 0 there automatically, because I don't want to make this a 1 and then multiply it by 18. I'm just going to do it right now, because if we did negative 2 row 2 plus row 3. We get this 1, 2, negative 1, 5. Then 0, negative 9, 9, negative 9. Right? Now, 0 times negative 2 is 0, so we get 0. Then negative 2 times negative 9 is 18, plus 18 is 0. This would be negative 18 plus 18 is 0. This would be 18 minus 18 is 0. So now you could say, okay, am I done? No, you're not. You say let z equal a. But this row has to be in row echelon form. So now I'm going to turn it into row echelon form. And you can do this in other steps. What I did here, you could turn one of these into a 1 in front first and then done it. But I just did it because it was simple. So 1, 2, negative 1, 5. And then we're going to do negative 1/9 row 2. Get 0. Negative 1/9 times negative 9 is 1. Then that'll be negative 1, 1, 0, 0, 0, 0. So 0z equals 0. So let z equal a. Right? So we have our first term. Z equals a. Now we plug it in. This will be y minus z equals 1. So y minus a equals 1. And then y equals a plus 1. Right? So now we solve for a. Now solve for x. X plus 2y minus z equals 5. X plus 2, a plus 1 minus a equals 5. X plus 2a plus 2 minus a equals 5. X plus a equals 3. X equals 3 minus a. So there, you just let z equal a if you have 0, 0, 0, 0, and then you solve for the rest, and you're in terms of a, and you're good. Thank you so much for watching. Please like and subscribe if it was helpful, and yeah, just thanks.